This video is about prime numbers. A prime number is, by definition, a natural number with exactly two divisors. For example, 1 can be divided by 1. So it has only one divisor, so it's not a prime number. 2, on the other hand, can be divided by 1 and by 2, so 2 is a prime number. 3 can be divided by 1 and by 3, not by 2, because then you don't get a whole number in return. So 3 is also a prime number. 4 can be divided by 1, by itself 4, and by 2, so 4 is not a prime number. And so on. There is a pretty good method to finding all prime numbers below a certain number. And in order to do that, first we're going to write down all numbers. Let's say we want to find all prime numbers below 50. Then we first start by writing down all numbers below 50. We start with the first prime number. 1 was not a prime number, but 2 is. 2 is a prime number, so anything that can be divided by 2 is not a prime number. So 4 is not a prime number, 6 is not, 8 is not, 10 is not, etc. And we cross out every number for which we are now sure that they cannot be prime numbers, because they can be divided by 2, so they have at least 3 divisors. Then we look at the next number, 3. 3 is a prime number, but everything divisible by 3 is not. So 6 was not, but we already crossed that out. 9 is not, 12 is not, 15 is not, 18 is not, 21 is not, etc. Now we've eliminated all numbers divisible by 3, we look at the next number, 5. And we cross out everything divisible by 5. And then we look at the number 7. So then 14 and 21 and 28. And eventually all you can cross out is 49, because all the others are already crossed out. Now let's look at the next number. And that is 11. So we have to cross out 22, already done, 33 and 44. So we look at 13. So 26 and 39, etc. we cross out. The next number on the list is 17, and 17 times 2 is 34, which we already crossed out, and 17 times 3 is higher than 50, so we can't cross that out anymore. 19, so 2 times 19 is 38, we already crossed that out. 3 times is again larger than 50, and we're going to see that from now on that the next one is larger than 50, so 23 is still here, and 46 is already crossed out, but all the remaining ones, like 29, 2 times 29 is already higher than 50, so everything we can cross out is somewhere in the numbers we haven't written down, so these numbers, all of these numbers, are prime numbers. Let's sum that up by writing them down in a comprehensive list. So we had 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47 are all the prime numbers lower than 50. This method of finding prime numbers is called the sieve of Eratosthenes. And if you extend the amount of numbers you write down to 100 or 150 or even higher, then you can find more and more prime numbers.